in the last example, we didn't have an angular acceleration. It was just a piece of bread falling to the ground, rotating at a constant rate. But what do you do if you do have an angular acceleration? So for example, a dentist drill where, dentist drills start from rest and they get to a certain speed after a while so that they can do their tooth work. What do we do in that case? The answer is you just do your classic laundry list in kinematic equations, but just with rotational variables instead of linear variables. Okay? So let's dive into this problem. A dentist causes the bit of a high-speed drill to accelerate from angular speed of 1.05 times 10 to the 4 radians per second to an angular speed of 3.14 times 10 to the 4 radians per second. Assuming a constant angular acceleration of 1.88 times 10 to the 5 radians per second squared, because it's angular acceleration, how long would it take for the bit to reach its maximum speed of 7.85 times 10 to the 4 radians per second if it were starting from rest? Okay, well, let's dive in. We're going to do a laundry list. We start here with omega 1, then omega 2, initial angular speed, final angular speed, then alpha, then theta, then t, right? This is just totally analogous to V1, V2, A, D, and T, right? But not in this chapter, buddy. All right, what is the initial speed? Well, the first two speeds, they're kind of red herrings, right? Really, this is asking if we're starting from rest now, in other words, 0 radians per second, right? How long would it take, so we're finding t, right, for it to reach a maximum speed of 7.85 times 10 to the 4 radians per second. So again, you don't need the first two values because really what the question is asking is for the time to get from rest to this, assuming an angular acceleration of 1.88 times 10 to the 5 radians per second squared. Okay, now, of our three kinematic equations, which ones do we use? Well, we have V1, V2, A, and T. So it sounds to me like the first kinematic equation would be the one that would be the most effective, right? So in other words, we have omega 2 equals omega 1 plus alpha t. Omega 2, once again, is 7.85 times 10 to the 4. Omega 1 is just 0. Alpha is 1.88 times 10 to the 5. And t is what we're looking for. And if I just do my algebra, that goes away, divide by 1.88 times 10 to the 5, I get a time of 0.4 seconds. So this thing is all fired up and ready to go in less than a half a second. That is a dentist drill. All right, pretty basic, right? It's just a kinematics problem. I'm only using different variables, the variables of the rotational world.